Welcome to EDU World Space.
We're asked to find the perpendicular distance from D to B to the force vector A to E. And this question is asking us to refer to a previous problem where we have already calculated the moment from D to B, the unit vector from D to B, and the force vector from A to E. So these are already calculated in the previous problem that the question is asking about. So to start with, we're going to first find the parallel component of this force vector A to E. So the parallel component, which I'll call F1, is going to be equal to the unit vector from D to B times the dot product of the force vector from A to E. So we can plug in those terms. So we plug in the unit vector. And then we plug in the force vector. And taking the dot product, we get a value of 51.6 newtons. And next we're going to find the perpendicular component of this force vector. So I can write out the equation. So the magnitude of the force vector is going to be equal to its components. So that's going to be the square root of F1 squared plus F2 squared, where f of 2 is our perpendicular. F2 is our perpendicular component. So we can plug in, so we know the magnitude and we know F1, so we can plug in those values. So this now becomes 55 is equal to the square root of 51.6 squared plus f of 2 squared. And solving this for f of 2, we get a value of 19.04 newtons. And we can now write out the equation. So the magnitude of the moment from D to B is going to be equal to the perpendicular component of the force vector f of 2 times the perpendicular distance from the two components, from f of 2, from the moment of D to B. So we know the magnitude of the moment, and we also know f of 2. So we can plug in those numbers. So we're going to have 2.28 is equal to 19.04 times D. And solving for D, so rewriting this and solving for D, we can get a value of D which is equal to 0.11976 meters.